Hi, this is Dave Johnson with another edition of Math Off Topics. Continuing to talk about limits in calculus. In this channel, I've talked about a number of different ways of evaluating limits. We talked about in other videos the conjugate methods, square root conjugate, cube root conjugate, even the trigonometric conjugates. In the last video that I did, we talked about the zero bounded limit theorem, and in videos to come, I'll talk about other ways of evaluating limits. Limits are important because they really occupy our time for the first few weeks of a calculus course. Without a good understanding of limits, it's difficult to really conquer calculus. So today I want to talk about the squeeze theorem, which is a powerful theorem that can find application in some problems. It's not going to be useful in all problems, and it's not always the best choice for doing a limit, but it's important that you understand it. And sometimes students get confused by the squeeze theorem. The name squeeze theorem pretty much tells you what it's all about, but let's get into it and we can see more details about this. So I've taken the liberty of just writing this stuff down ahead of time so I don't have to spend so much time writing. But let's break this down. So the statement of the squeeze theorem, if functions, and we're going to suppose that there are three functions, f of x, g of x, and h of x, and they don't have to be continuous, but as long as f of x is less than or equal to g of x, and that those are less than or equal to h of x, for all values of x near some point x equals a, and by the way, a can be infinity, then, and it's possible also that this inequality, and this is a compound inequality, I'll have more to say about that as we go through the example, but as long as this inequality holds, except possibly at x equals a itself, then, and if the limit of the leftmost function is the same as the limit of the rightmost function, then by the squeeze theorem, by the squeeze property, the function that's in between is going to have the same limit. In other words, the limit of g of x is going to be the same limit. We're going to call that L, just as a handle. So the limit doesn't have to be zero, although oftentimes it is, but it doesn't have to be. And you can see this demonstrated on the graph. So I've got three functions, f of x, g of x, and h of x. And at least in this interval, and let's say near a, and I'm not specifying exactly what near means, but near enough so that we can actually find the limit and so on, then as long as this inequality holds, in other words, as long as g of x is between the f of x and the h of x, so it's squeezed in there, okay? If that function is squeezed in there, and I'm going to show you examples, or one example in this video of that happening, then whatever the limit is of f of x and the limit of h of x, assuming that they are equal at x equals a, then the limit of g of x as x approaches a has to be the same value. That's what the squeeze theorem says. Okay. Now you might want to spend a little bit of time and think about this and look at the graph and make sure you understand what the graph is really saying. But let's go ahead and do an example. So in this case, let's say we're trying to evaluate the limit as x goes to 0 of x to the fourth times cosine 2 over x. Okay. Well, if we're going to use the squeeze theorem, and by the way, there are other ways to do this problem, but if we're going to use the squeeze theorem, then we have to have an inequality, right? We have to have this fact, this condition for the theorem to hold, And we also need to have that these limits exist and are equal. But let's suppose that we can come up with that inequality. So, well, you see the cosine of 2 over x, one of the common things that's done in a problem like this is to say, well, okay, so -1 less than or equal to cosine 2 over x is less than or equal to +1. And we can say that because the cosine function is bounded between -1 and 1. The range of the cosine function is -1 to 1. So no matter what the argument of cosine is, in this case 2 over x, no matter what that value is, the cosine of 2 over x, or cosine of whatever that is, has to be between -1 and 1. Okay. Now we're not done, because what we need is to have this x to the fourth times cosine 2 over x in that inequality. So we're constructing an inequality here. And in order to uh, use the squeeze theorem, we have to have a valid inequality. So I'm going to multiply both sides by x to the fourth. So x to the fourth times -1 is negative x to the fourth, less than or equal to x to the fourth times cosine of 2 over x, less than or equal to x to the fourth times 1, which is x to the fourth. Now I can do that because x to the fourth is positive for all values of x. This wouldn't work if it was x cubed, because x cubed can be negative. And so we'd have to take a different approach in order to make sure that we got a legal, correct inequality. But in this case, x to the fourth is positive for all values of x. And then once we have this, we have the x to the fourth cosine 2 over x, which is the function that we want to find the limit of. But it's going to turn out to be easy to find the limit of the, we can call this our f of x. This is our h of x. And this, of course, is our g of x. And we want to find the limit of g of x as x approaches 0. Well, okay, so what is the limit of f of x? So limit as x approaches 0 of f of x, well, that's the limit as x approaches 0 of negative x to the fourth, but of course that's 0. And also, let's go to the far right, so limit as x goes to 0 of h of x, that's equal to the limit as x goes to 0 of x to the fourth, because x to the fourth is h of x, and of course that's 0. And by the squeeze theorem, if the left if the limit of the left function, limit of f of x, is the same as the limit of the right function, uh, this is f of x, this is h of x, if that limit is also the same as this, and we called it L here, but in our problem it's 0, so they are equal. So therefore, I can write therefore limit as x approaches 0 of g of x, which is limit as x approaches 0 of x to the fourth times cosine 2 over x. Well, that's going to be the same as what we got for the other limits. So our answer is 0. Now, so I hope this has been helpful. And if you found it helpful, if you enjoyed the video, please like and subscribe. And I look forward to seeing you next time.